Z direction. Let's do another one. A little more involved problem. A 10 centimeter length wire carries a current of 4 ampere in the positive Z direction. The force on this wire due to a magnetic field B is negative 2I plus 0.2J Newton. If this wire is now rotated so that the current flows in the positive X direction, the force on the wire is F equal to 0.2K Newton. Find the magnetic field B. Well, this is a little more involved problem. Here we have two situations. First, the current is flowing in the positive Z direction. And at that time, the force on that conductor is this. And the wire is rotated so that the current flows in the positive X direction. The new force is this. We got to use these two situations. Alright, let's pick the data. The length of the conductor that carries current is 0.1 meter, 10 centimeter. The current is 4 ampere, so I is 4 ampere. The force is given to be negative 0.2I plus 0.2J Newton. Now, I times dl is 0.4K. Why? Because the current is in the K direction. So IDL is the vector that is 0.4K. Now, you know that F equal to IDL cross B is the cross product of these two vectors. Now, we know both the vectors. The vector IDL is 0.4K and the vector B is this. Alright, let's take the cross product and see what happens. Well, we don't know B, do we? We know the vector F. We know IDL, but we don't know B. We need to find B. So, let's start by saying, let B be BXI plus BYJ plus BZK. Well, they are the three components of the magnetic field of B. So, let B be BXI plus BYJ plus BZK. Now, let's put all these in this equation. We know the vector F. That is the vector F. We know IDL. That's the vector IDL. And this is the vector B. Now, putting it all together, we have F equal to IDL cross B. And that is, I replaced F by 0.4K. So that will be 0.4K cross B, BXI plus BYJ plus BZK. Now, we take the cross product. When you take the cross product, the first one will be 0.4K cross BXI. Now, what is K cross I? You remember that one? Look at that. We need K cross I, K cross J, and K cross K. Well, and that quantity will be equal to that F. Well, I'm going to come again. Now, F is the vector given by this. This is the IDL vector, not F that I said first. 0.4K is the IDL vector, cross, this is the B vector. So IDL cross B equal to the force vector. Alright, now you know that K cross I equal to J. That means 0.4K cross BXI will be 0.4 BXJ. Is that right? Because K cross I equal J. And K cross J will be negative I, and K cross K will be 0. Alright, let's use that to write this now. And now, I have 0.4 by negative I. I wrote that first because that is the x component. Look at that. 0.4 k cross by j. K cross j is negative I. 0.4 by I. Now let's take this product. 0.4 k cross bxi. K cross I is j. 0.4 bx j. So the product, this product will now give you this. Y k cross k is 0. And therefore, negative 0.4 byi plus 0.4 bxj is the force vector that we already know. Now, we can now equate the x components and the j components and obtain by and bx. Is that right? So what is by equal to? By equal to negative 0.2 divided by 0.4, that is 0.5 Tesla. And bx equal to 0.2 divided by 0.4, that is also 0.5 Tesla. So by and bx both are 0.5 Tesla. Well, we found the y component, we found the x component, we now need to find the z component. And that is where we're going to use the second situation. Alright, can you go back and repeat the same process for the second situation? That is, when the conductor is rotated so that the current is now in the x direction, the new force is 0.2 k. Let's use that. We have bx we know, we calculated, by we know, and the ideal vector is now 0.4i. It is now in the x direction. Now, when the current flows in the positive x direction, ideal is a positive x vector and is equal to 0.4i. And therefore, look at it again, ideal cross b equal to f. Is that right? Force is the cross product of the vector ideal and the vector b. Now, this time ideal is 0.41i and the vector b is bxi plus byj plus bzk, where we calculated bx and by, we don't know bz. And the force vector this time is 0.2k. Now, use I cross I equal to 0, I cross j equal to k, and I cross k equal to negative j, and so 0.4i cross bxi, that will be 0, and 0.4i cross byj will be 0.4 byk, because I cross j equal to k, and 0.4i cross bzk will be negative 0.4 bzj, because I cross k is negative j. So the left hand side simplifies to this, and the right hand side is 0.2k. Well, we know by, therefore we can now find bz, the z component. And that will give you bz equal to 0. Therefore, the magnetic field is 0.5 Ti plus 0.5 Tj, and the z component is 0. That has been a good problem, and take some time and practice this problem.